Hello everyone, I'm Ding Yan from HollySys Research Center. Last year, we launched a demonstration event on OPC UA WebAPI, which is a competition hosted on OpenAtom platform. As a technical advisor of OPC Foundation China, I have been involved in organizing this event from the very beginning. So I'm excited to share with you the highlights from this competition. Firstly, let me give an overview of OpenAtom. OpenAtom is a code platform similar to GitHub, which is located in China. This platform was founded in 2020 by major Chinese IT companies such as Huawei, Tencent, and Alibaba. Until now, this platform has hosted numbers of open source projects, including top-level projects like operation system, database, and software framework. Besides the open source platform, OpenAtom organizes competitions each year to attract new participants. OpenAtom will fund sponsors to publish specific requirements for a competition, and the teams who are interested by the technology or reward will be invited to contribute their source code on OpenAtom. And finally, source code from those teams will be estimated by a technical judge group, and the winning team will be selected and get their rewards. The technical specification of UA WebAPI was released in 2024, and in the same year, OpenAtom began to focus on new technologies related to industrial. So when I heard about this news, I want to initiate an OpenAtom competition for this new OPC technology. By sending an email to OPC Foundation, I get a quick feedback from Huawei, and seeing they are interested and willing to sponsor this competition. And after a short discussion, we decide to launch a series of competitions on OpenAtom. So for the year 2025, we will focus on putting the Web API on top of existing UA technologies. And after that, for the coming years, more capabilities of this Web API will be showcased, such as DPP, digital twin, and AI. That is how the competition starts. In September 2024, we published our invitation on OpenAtom website by explaining the technical requirement of UA Web API and the award for the winners. After 3 months, on the code platform, we received source code from 34 teams from enterprise, universities, and individual developers. Then, our judge began to review their code to find qualified teams. After first round of selection, 7 teams are qualified and invited to join the final round competition, which is a roadshow physically held in Guangzhou, China. During this event, candidates are required to present their source code and demonstrate their program on live. Finally, the judge will assign scores for each team, by which the rank and award is determined. This page is the overview of those projects. On the left hand, you can see there are 3 layers related with OPC UA Web API. They are data source layer, web service layer, and application layer. The data source layer consists of applications that provide OPC UA data to the UA web service. Examples include protocol gateways and PLCs, which deliver OPC UA data. The middle layer is responsible for collecting OPC UA data and sharing it with UA Web API. On the south side of this service, UA clients or subscribers are integrated. And on the north side, the web service application and the web controller code is implemented. The top layer consists of applications that utilize OPC UA data with UA web client. Most showcases are HMI to visualize data from the web service, and the showcases which exchange data between the service and the low-code platform is also demonstrated in this application layer. As a result, with those three layers, interoperable IIoT application consists of different providers are showcases. In the following pages, the winning application of each layer will be presented. The winning showcase from the data source layer is a gateway provider with over 20 years of experience in industrial communication. Protocols ranging from factory automation, energy, and infrastructure is supported by their product. To prepare OpenAtom competition, this team added UA publishers functionalities into their gateway to enable OPC UA communication with the cloud. On the right side, we can see more details. In the engineering stage, user can utilize the configuration tool of the gateway to configure data tags and the communications to Modbus simulator. Then, user need to set up the UA publisher to let the gateway exchange data with MQTT broker. Once the configuration is done and downloaded to the gateway, the backend program will start communication with Modbus simulator and publish OPC UA payload to Huawei Cloud. Finally, to visualize the data published to the cloud, OPC UA monitor from HollySys OPC is utilized. The winning team in the application layer is a HMI vendor who provides web-based HMI with 2D and 3D features. Their product also offers an easy-to-use HMI editor, which can help developers to quickly design their graphical interface. To communicate with UA web server, the product team implement OPC UA web client in their product. And because this web client is very friendly with web-based applications, so their development jobs are going very quickly. On the right hand, there are some highlights of this showcase. For example, in the human-machine interface, you can see diagrams, equipments, control panels, and charts. All the data for those graphical elements are from OPC UA web service. Here is the champion, an OPC UA web service gateway, which is able to communicate with existing OPC UA servers. This service is developed by a system integrator from watch manufacturing industry. The right side is the software architecture, which is a typical web service implementation, including modules like API, gateway logic, and UA client communications. The main focus was to implement the gateway module, because the rest of them are already available on open source. And in this module, the team are developing mapper codes to convert payload between UA WebAPI and OPC UA servers. Okay, that is introduction and highlights for this competition. Hope you find them interesting. In summary, unlike vendor-locked IoT system, the standardized OPC UA WebAPI is able to decouple an IoT system into independent components. As a result, customers will have more flexibility in selecting the solutions and can integrate them according to their needs. On the data source layer, users can choose providers offering PLC, gateway, or simulator with OPC UA communication capability. And the integration to an OPC UA web platform will be very easy and fast. On the service layer, integrator can deploy a UA web service on-premise or on the cloud, depending on the requirement of their project. For the application layer, users can have a list of solutions supporting UA Web API. And in general, they are providers specialized in their area. By building an ecosystem this way, an IoT platform will become more flexible and cost-effective. The OpenAtom competition of this year is successfully concluded, but UA Web API on OpenAtom will continue. Our next step is to integrate it to a wider range of systems. That means the data source will not only be limited with the machine data, but data from IT systems like Circle database, RESTful API, or file system will be integrated. Once the OPC service is ready for those systems, UA models of different domains will be available, such as work order, product passport, or process design. By utilizing those models with OPC UA interface, applications like DPP, engineering tool, or technologies such as AI or administration shell will be able to interact with each system in a standardized way. To prove this concept in China, DPP standard will be the next competition for OpenAtom 2026. Implementation of DPP in China is a challenge because of the diversity of the systems. Those systems are from different vendors with different interfaces, and they are deployed in multiple layers such as factory, enterprise, and cloud. On the other hand, local companies and developers are not familiar with standards such as DPP and AAS, and that will make the integration work difficult and expensive. But thanks to the decentralized approach of OPC UA Web API, this service can be integrated into each of those systems by providing standardized data and interface to the central platform, such as Catenary-X. So, an open source project on OpenAtom will be very helpful to show the technical roadmap of DPP over OPC UA. And by those showcases, teams will be attracted by the new business opportunity and become technical providers on DPP data service. OPC UA WebAPI is still in its early stage, but it has more potential to be explored in the future. To make it better, events and competitions will be organized for the coming years, and applications such as digital twin, digital thread, and AI will be showcased. On the final page, let's talk about market opportunities for OPC UA. From my observation, the demand for smart manufacturing in China and in the world is growing fast, because the market is becoming more and more uncertain. As a result, customers began to find production solutions with more flexibilities, which is able to respond to the market change fast. Modular and plug-and-produce automation systems are becoming an important requirement for production systems. By using an orchestration tool, independent components can be integrated fast, and the engineering work are becoming much more easier. Integrating automation into entire life cycle is another key requirement, because this will accelerate the innovation. In that case, the product and the process designer will become the conductor of their production system. Once process is designed and tested, software components need to be configured and orchestrated automatically based on those requirements. Seamless integration between IT and OT systems is also important for flexible production. On the automation side, meaningful data and standardized interface must be provided for IT systems, such as device health, recipe, and job control. Once the integration jobs are simplified, highly integrated systems such as order-driven production or smart production level 4 will become cost-effective and widely used. As you see, in all those scenarios, OPC UA is playing the key role. Once the system is designed this way, well-organized data is provided to AI, which will further enhance every stage of the production system, such as engineering, development, and the human-machine interface. Finally, let me introduce myself. I'm a technical engineer from HollySys, which is a Chinese automation company that provides automation and software solutions. And our use cases are ranging from process industrial, electricity, railway, and medical industrial. At our research center, I'm focusing on technologies such as OPC UA, module type package, and digital twin. Since 2012, I became a technical advisor of OPC Foundation China by supporting some localization tasks such as technical exchange, standardization, and trainings. With decades of research and development, I believe that the time is coming for smart manufacturing and related technologies like OPC UA. So let's make it happen together. And thanks for listening.